Hello students, this is the another part of series of joint probability density function. So in this part of joint probability density function, I am going to discuss few concepts with the help of this particular question. As you can see in this question, two random variables are provided and joint PDF is given by this. fxy is 6x square y, where x is from 0 to 1 and y is also from 0 to 1, otherwise it is 0. So in this one we are having two parts, part A and part B, and in part A we have to verify this condition. In part B, 1, 2, 3 and 4 terms we have to evaluate. So first of all, I will be taking care of this first part, A part. So we have to verify 0 to 1, 0 to 1, fxy, 0 to 1, 0 to 1, fxy, dx, dy. So I will be evaluating this particular part. So here 0 to 1, 0 to 1, x is from 0 to 1, y is from 0 to 1. For this particular range, what is the value of fxy? That is 6 x square y dx dy. So 6 I can take before the integrations, 0 to 1, 0 to 1, x square y dx dy. So this is not double integration, so I will be solving it for x first, 0 to 1 x square dx and then dy 0 to 1. So what it would be for this particular integration, it will be x cubed by 3, 0 to 1. And one more thing here, with respect to x, y we can write like this, so y will also be here, so it would be like 0 to 1 y dy, because for x y is treated like constant, so that is why I have written y here. So it would be now 6 by 3, 0 to 1 y, and it is like 1 minus 0, that is dy, I mean to say into dy. So it is 2, 0 to 1 y dy, or it is 2 y square by 2, 0 to 1, I mean to say 2 into 1 by 2, that is 1. So in such a way I have proved the first condition, that is 0 to 1, 0 to 1, fxy dx dy is equal to 1. So that is quite easy to implement. Now thereafter we have to prove this, we have to obtain this particular probability. So what is the probability here? In this part, x is from 0 to 3 by 4 and y is from 1 by 3 to 2. So let me just continue this here. So x is in the B part. First of all, we have to find probability of x from 0 to 3 by 4 and probability of y from 1 by 3 to 2. So what it would be? Again, I will apply the formula here. The formula is here, that is minus infinite to infinite, basic formula I am writing, minus infinite to infinite fxy dx dy. Originally in our question, x is actually in between 0 and 1, y is also in between 0 and 1. So this range is from 0 to 3 by 4. So for x I will be writing, and 3 by 4 will lie inside the interval 0 to 1. So for x I can write 0 to 3 by 4, and it is the limit of x, so dx, and for that particular range, PDF is defined like this, 6x square y. Now thereafter for y, what will be the limit? Our limit will be, as you can say, it is 1 by 3 to 2, but upper limit of y is defined at 1 only. So limit of y will be here 1 by 3 to 1. Yes, that is the updated limit. Now thereafter what we can do here, we can just take this 6 outside. So it is 6, and thereafter 0 to 3 by 4 x square y dx, and 1 by 3 to 1, and it is dy. With respect to x, in the double integration y will be constant, so that is why I will write it like this: 6 and 0 to 3 by 4 x square dx, y I can take outside, dy, and it is 1 by 3 to 1. So it is 6, and I will just integrate it: x cube by 3, 0 to 3 by 4 dy, and it is 1 by 3 to 1 of y. So what it is going to be, it is 6 by 3 means 2, and 1 by 3 to 1, and just it is like y into 3 by 4 whole cube, and into, okay, this 3 is already done, it is already divided, so it is just like this, only 3 by 4 whole cube of dy. So I can take this term before integration, so 2 into 3 by 4 whole cube, and it is 1 by 3 into 1 y dy. So 2 into 3 by 4 whole cube, and thereafter what we'll be getting here, 2 into 3 by 4 whole cube into its integration is y square by 2 and 1 by 3 to 1. So what it is going to be, 2 and 2 will be cancelled out. Yeah, it is 3 by 4 whole cube y square 1 by 3 to 1, that is 3 by 4 whole cube, it is 1 square minus 1 by 3 whole square, so it is 3 by 4 whole cube 1 minus 1 by 9. Ultimately it is going to be 1 minus 1 by 9, so we can write it like 3 by 4 whole cube into 8 by 9. 3 by 4 whole cube into 8 by 9, so that will be our final answer. If you will solve it, you are going to get here 3 by 8, which you can verify later as well. Now this was the final answer of this particular term. Let me check the question again. This particular term I am talking about, probability of x from 0 to 3 by 4, and probability of y, I mean to say comma, y is from 1 by 3 to 2. Now if you can see here, the next term is probability of x plus y less than 1. So I am going to solve it right now. So students, if I will talk about this particular term, probability of x plus y less than 1. So first of all, I will draw some reason here. If you know the basic, this is a line, origin, and this is a line y equal to x. So students, this is the line y equal to minus x. So what will be the line y equal to 1 minus x? It will cut at 0 1, and here 1 comma 0. So this will be the line y equal to 1 minus x. Ultimately we can write line x plus y equal to 1. Now we have to just work upon this reason, where x plus y, if I am writing it like this, x plus y less than 1 means limit of y should be less than 1 minus x. So less than 1 minus x means this particular, in such particular way. So what I will do, I will draw a vertical strip here, vertical strip of y. Here y will be 0 on x-axis, and at this point y is equal to 1 minus x, and I will, if I will take just this strip from x equal to 0 to x equal to 1, this whole region will be covered, this whole region will be so I can highlight this region here, I can highlight this region. So now in such a way we can get the limits. So here as you can see, limit of x will be 0 to 1, and limit of y will be 0 to 1 minus x. So students, it is the constant limit, okay, and it is a variable limit, it is the variable limit. So in the concept of double integration, we will first solve the variable limit and then we will solve the constant limit. So I will just write the terms like this. It is like probability of x plus y, let me write it again, probability of x plus y less than 1 is equal to, so limit of y first, limit of y 0 to 1 minus x of fxy, fxy, let me write all these things in a small in order to maintain this symmetry here. Fxy, it is just like, otherwise you can write the whole term in capital X capital Y as well, no problem. So it is 0 to 1 minus x, and it is a limit of y, and it is dx, and thereafter limit of x is 0 to 1. Now what I can write here, it is 0 to 1 minus x, it is students 6x square y dy and dx, and here it is 0 to 1. And now I will not solve this in double integration again, because such type of double integrations I have already taught you. So this you can verify by yourself. So I can provide you with this particular answer. It will be 1 by 10, and I have told you that how to draw the reason in such type of part. So that thing I have just already discussed. So students, it was all about the second term of B part. So this part is also done. Now thereafter we will talk about the next third term of B part, probability of x greater than y. So what would be the probability of x greater than y? Okay, probability of x greater than y, just wait a minute. Yeah, probability of x greater than y. So for this students, we know how to draw the line y equal to x. Okay, y equal to x. So if I say x is greater than y, so we can write like y is less than x. X is greater than y means y is less than x. So y is less than x, so this is the line y equal to x. This is a point 0, 0. So students, in such a way, what would be the value of, what is the value of, I mean to say, y is less than x means this particular way y will exist. Okay, but how to take the limit of x? For that I will be taking the original limit. Original limit means here I will draw the line x equal to 1. So this is 1, 0. So what it would be, here I will be taking vertical strip, and in this strip y equal to 0 here and y equal to x here. And if I will be taking this strip from x equal to 0 to x equal to 1, this region will be created. This particular region will be created. So what we can do here, I will just write it like such a way. Probability x greater y is probability y less than x. So probability y less than x means what? I can define it by this reason. So double integration. Double integration, I will say here limit of x is from 0 to 1. From this particular region we can decide, and limit of y is from 0 to x. So limit of x is constant, it is constant, and limit of y is variable. Limit of y is what? It is variable. So I will solve for limit of y first. So it is 0 to x and fxy, 0 to x, I will write in small again, and dy, and then limit of x, and that is from 0 to 1. So now students, this value also you can find out, and that value will be equal to 3 by 5. So my main concern is here to tell you how to find the limits based upon the reason, okay, in this double integration, because that is the main concept here in such type of questions. Students, I will just try to find this particular last term, I mean to say this particular question based upon conditional distribution, x less than 1 and y less than 2. So next is like probability of x less than 1 given y is less than 2. So it is like probability of x less than 1 intersection y less than 2 upon probability of y less than 2. What we can do here, try to understand. X is less than 1, how I will draw this region, x-axis. This is suppose here x is from 0 to 1. Yeah, I will take it from here. So it is 0, 0, it is 1, 0. X is less than 1, so it will be just like this, x equal to 1, and this is just about, this is x-axis, this is about y-axis. Now x less than 1 means this particular way it would be. Now y less than 2, so suppose this is y equal to 1, I mean to say this particular point will be 0 comma 1. This particular point will be 0 comma 1 and this particular point will be 0 comma 2. Now y less than 2 means if I will draw a line here at y equal to 2 means this particular this, and this particular line will be what? It will be y equal to 1. Y equal to 1. So now intersection of what? Intersection of x less than 1, so this way, and y less than 2 this way. So what is the intersection of this? If you see, intersection of this is just this particular region, just this particular region. So in this particular region you can see the limit of x will be x equal to 0 to x equal to 1, and limit of y will be y equal to 0 to y equal to 1. So that is what we can just try it separately, try to solve it. X less than 1 intersection y less than 2. Okay, so I'm solving it separately here. So as I told you, here limit of x is from 0 to 1, limit of y is also from 0 to 1. So it would be like, I mean to say 0 to 1, 6x square y. Suppose first of all we are solving for x, both limits are constant, so and then dy and 0 to 1, and we know how to solve it. So I'm giving you the final value of this will be 1. So if I will be putting this value here, so this will be 1 upon probability of y less than 2. But now students, our next aim is to find probability of y less than 2. How to evaluate? Probability of y less than 2 means what? So probability of y is less than 2, but we have to take the original concept. Our original limit is x is between 0 to 1 and y is between 0 to 1. So upper limit is actually defined for 1 only. So we have to take here limit of x as it is, because here no limit is given upon x. So we have to take x as it is given. 6x square y, 6x square y, and I will write it like this, 6x square y dx, and then limit of y, and limit of y is also 0 to 1, and this will be also 1. So I can define it like 1 upon 1, ultimately it is equal to 1. So students, this was the last part of this question. Let me recall the topic again. So students, in this particular question, what are the things which I have obtained? Firstly, I proved this condition 0 to 1 fxy dx dy is equal to 1. So I told you how to solve it with the help of double integration. Then I discussed this part of the question for certain limits of x and y and its probability. Thereafter, in the next part of B part, I mean to say next concept of the B part, we evaluated probability of x plus y less than 1 from this particular graph with the help of. After that, we went for this particular aspect where probability of x was greater than y, and at last, I mean to say after this particular topic, we just evaluated conditional probability of the conditional distribution x less than 1 given y less than 2. So students, this is quite interesting topic in the concept of joint probability density function. So I hope this topic and this video will be very helpful for you in your studies. So thank you so much for watching this video.